Now, we are going to start with aldehyde ketones. Now, we are going to start with aldehyde and ketones. Regarding acids, we can see separately. Even though it is a small chapter, we will see it separately. Now, first, you will learn some common reaction in aldehyde ketones. But many reactions are repeating and again, that's all. See, first one, any primary alcohol on partial oxidation using chromium anhydride, it gives aldehyde. That's all, very easy. And if you want to know, on reduction, it goes back to using sodium boron hydride, it goes to the primary alcohol. So, keep it in mind, primary alcohols and aldehydes are interrelated. Primary alcohols and aldehydes are related. Secondly, you are going for secondary alcohol. Partial oxidation, same chromium oxide. What you will say? It will give a ketone. I have just already mentioned these reactions. Give ketone. Ketone on reduction, it gives primary alcohol. These are all very simple reactions. So, okay. Second one is very important. Be careful. Second one is very important. Ozonolysis. You are going to see about ozonolysis. What is the purpose of ozonolysis? To locate the unsaturation. To locate the unsaturation in organic compound. That is a double bond. Double bond in organic compounds. So, okay. First, I will start you with propylene. I am starting with propylene. Propylene on ozonolysis, first you watch this double bond. That's very important. What you do? You remove the double bond. That means you remove both the bond. Then what we should do? You should create a ozonide. You should create an ozonide. Ozonide means all the three combined in a ozonide form. The compound generally is called as ozonide. Then what will happen? It undergoes hydrolysis. It undergoes hydrolysis. Then hydrolysis means just to break the compound like this. You cleavage the compound like this. That's all. You will be getting the corresponding compounds. You can watch this compound CH3CHO. You put zinc if you want. CH3CHO plus. You see this one, CH2O. This is CH2O. This is CH3CHO. This is CH2O. CH2O means, don't write like this, it is formaldehyde. That's all. You write like formaldehyde. So, okay. So, propylene on ozonolysis, it gives formaldehyde and acetaldehyde. Okay. I am going for the next compound like this. I am going for the next compound like this. Then what will be the product? You see, CH3CH, it's here. CH3, that's all. Here also CH3. Then you break the compound CH3CHO, CH3CHO. So you are getting both acetaldehyde and no formaldehyde. That's all. Since it is a symmetrical unsaturated, it gives same compound. Okay. Next one, you can go for branched compound like this. Isobutylene branch. What will be the answer? You go slightly like this. As usually, what should you do? You first break the double bond and create a ozonide. First you break the double bond and create the ozonide. Then break the ozonide. You will be getting CH3CO, CH3 like this. CH3CO, CH3. Then this one already I told you formaldehyde. That's all. Here also you can check the product without writing. You can check the product. How? Like this. You can check the product. CH3, CO, CH3, formaldehyde. Here also you can check the product by adding 2 oxygen on both sides. You see, CH3, CHO, CH3, CHO. This is how you learn the ozone compound, ozonolysis reactions. But for ozonolysis, double bond is very important. Without double bond, you cannot go for ozonolysis. So, okay, ozonolysis, then reaction with Grignard reagent. Reaction with Grignard reagent means already I told you. But why I am just remembering here? Because it is an important reaction. So, I am just recollecting here. Shortly I am doing, not fully. You see, primary alcohol, secondary alcohol, then tertiary alcohol. That's all. Already I told you about all this, repeating again and again and again. So, these are very important reactions. Okay. Next one, what I am going to tell about is calcium salt. Calcium salt distillation. But it is not in your book, but it may be in your question. It is in your question. Sir, okay. You see, this is the calcium salt, common formula. This is the calcium salt. Distill. Distill means heating. Generally, what should understand before entering into this one, you should know that any calcium salt on heating will give calcium carbonate first. You remove the calcium carbonate by putting a round and find the remaining compound RCOR. You see, RCOR. This is a general formula. Now, if you want, I will apply for calcium formate. What I will do, if you ask me suddenly what is the product found when calcium formate is heated, I will tell I don't know anything about it. But I will go slowly from my basic one. How? You actually remove the calcium carbonate. First you do this one and find the remaining compound. By seeing the remaining compound, you write like this. That's all. If somebody asks you calcium acetate, means you write calcium acetate and check the answer, you will be getting, you see here, CH3, CO, CH3. The product will be like this. CH3, COCH3. If somebody asks you, sir, calcium benzoate, what can I do? They ask for calcium, same thing. C6H5, CO, C6H5. You see? That's all. If you learn this concept, you can answer all the questions regarding the calcium salt. You can be highly free. Then next one, you can ask me, what will you do if you have 2 calcium salt distillation? When you heat 2 calcium salt, of course they may feel it's complicated. If anybody want to ask some tough question means, they'll ask for 2 calcium salt like this. Calcium acetate with calcium formate. Like this, they'll ask 2 salt. What should do? How to calculate? Very simple. You first write CON. You first write CON. That's all. You see, you're having CH3. Okay, you write CH3. Here you are having hydrogen, so you write the hydrogen. That's all. And as usually, you write calcium carbonate. That's all. Because of 2 calcium salt, you go for the formalities. That's all. This is a formality 2,2. What is the product? Acetaldehyde. The product is acetaldehyde. But somebody will teach like this. That is also, if you like it, you can go like that one. How? These 2 combine to form a mixture of calcium salt, like this. Mixture. Now you heat the calcium carbonate. You see, directly you will get the product. You are the deciding factor. If you feel this is easy method and your school accepts, then you go for this one. Or if you feel this one is very easy, you go for this one. That's your deciding factor. If somebody asks you calcium benzo with formaldehyde, if somebody asks like this means what I will tell you. That's all. You see, benzaldehyde. The answer is benzaldehyde. That's all. Then if somebody asks you calcium acetate, if somebody asks you like calcium acetate with calcium benzoate, I hope you feel very easy. You see, you are having CH3, so you write the CH3. You are having C6H5, you write C6H5. So the product will be acetophenone. The product will be acetophenone. That's all. This is how you should play with calcium salt. Don't read and all, and don't go for this kind of double bond and all. Not at all necessary. Why? This is all waste. Learning like this. Okay. Calcium salt is over. Next one, we are going to see with hydrogen cyanide. We are going to see with HCl. Okay. You see, when you treat with HCl, what will happen? The H will join in the top like this, and Cn will join here like this. Or you can write like this. If you want, you can write like this. Like this also you can write. If you write like this, what you would say? What you would say? Sir, H in the top, Cn in the side. Both are correct. Of course, both are same. So, simultaneously, it undergoes hydrolysis. It undergoes hydrolysis. What will it do? Go for the common reaction. What common reaction says? Cyanide on hydrolysis gives acid. That's all. You see, it gives the acid like this. If you write like this, you will write like this. It is all you are the deciding factor. This is a common reaction. Okay. We'll go for the reality, how we should apply. If somebody asks you for acetaldehyde, how will he ask you? Acetaldehyde with the HCN followed by hydrolysis, what you should do? You change all the CH3, all the R into CH3. That's all. What is the name of this compound? Generally the compound is known as cyanohydrin. That's all. When used for acetaldehyde, it is called acetaldehyde cyanohydrin. And what is the name of this product? This is lactic acid, which is present in the curd. Lactic acid. So somebody, how will they ask? How will he convert acetaldehyde into lactic acid? If you want, you can apply like this or you can apply like this. Both are same. Okay. If somebody asks the same reaction for benzaldehyde, same reaction for benzaldehyde means all you write as phenyl. What will be the name of the compound? Mandelic acid. When you apply for benzaldehyde, you will call as mandelic acid. Or you should go for iupactane. Okay. So this is reaction regarding with HCN. Next one, we are going to see with sodium bisulfite. Next one, we are going to see with sodium bisulfite. This is an addition product. You see Na at the top, SO3 Na at the bottom. That's all. What is the name? Generally, it's called as bisulfite compound. We can't have any real name. So, generally, it is called as bisulfite compound. What is the purpose of giving this type of reaction means? In problem, they will tell like this. A compound A, when treated with sodium bisulfite, it gives a bisulfite compound. Means what they are trying to say? What they are trying to say indirectly? The compound should be an aldehyde or a ketones. That is the way they are trying to insist you regarding sodium bisulfite. Moreover, there is no very important regarding the questions and all. Next one, you see, many are highly irritated with this type of reaction, but it's very easy. You see, you write the carbonyl compound like this. You may ask me, why you are writing the O focus to the other side? Because I am going to remove the oxygen for water. If I write like this, in the middle means I cannot remove the water easily. That's why I am focusing on the one side. Okay. If they give this compound, it is very easy. What you will tell, sir? It is very easy. The product is like this. That's all. The product is this one, and the name is oxime. That's all. This is hydroxyamine. This is hydroxyamine and the product is oxime. This also you can apply for aldehyde also. You can apply for aldehyde or you can apply for ketone. Both are okay. So, you keep it in mind when you treat with hydroxyamines means you are getting the oxime. So, okay, then I am rubbing over here. You see, I am rubbing over here, just slightly changing the compound. Changing the compound. What is the name of this compound? Hydrazine. The name is hydrazine. So, what will be the product? You see this one. Don't go for the answer. You see this one. Sir, N is that? NH2. That's all. That's all. What is the name of the compound? This is hydrazine, that is hydrazone. The compound will be named as hydrazone. Okay, next one. If somebody asks you phenylhydrazine, you write the answer for phenylhydrazine. Okay, you should go for phenylhydrazone. That's all. This is the technical way of learning the organic chemistry. Don't reject all equations. If you want to get very, very good marks, means you learn the technical point of view. Then last one in this one. In this category, the last one is semi-carboxylic. If somebody asks about semi-carboxylic, this is the formula. NH2, NH, CONH2. This is semi-carboxylic. So, what is the product? What is the product for this? H2 is removed, NH, CONH2. That's all. Semi-carboxylic, semi-carbazole. But many will ask this question. Why? Because here also you are having hydrogen. You see, you are having hydrogen on both sides, which you have to remove. You have to remove which is attached to NH. This you have to remove, which is attached to the NH. You should not remove this one, which is close to the CO. So, okay, this category is over. Next one, what we are going to see, aldehyde ketones. First level. First level means which you have to learn, that's all. It's a very important. Okay. First one is Rossmann reduction. When anybody says Rossmann reduction means you just think about it. Acetyl chloride to acetaldehyde, that's all. You see, this is methyl chloride. This is only acetyl chloride. Don't confuse regarding acetyl and methyl. This is methyl chloride, this is acetyl chloride. But here, the barium sulfide is acting as a poison for the catalyst. Is acting as a poison for the catalyst. Suppose, if you just forget to use barium sulfate, what will happen? This will be further reduced into alcohol. Again, it will be reduced to alcohol. So, the purpose of using barium sulfate, this is catalyst. The purpose of using barium sulfate is to prevent further oxidation. Okay. This reaction you can apply even for benzoyl chloride. When you apply for benzoyl chloride, you will be getting benzaldehyde. So, okay. Next one, you are going to see Clemmensen reduction. Clemmensen reduction. What did it say? He converts CO into CH2 using tin bar con HCl. Okay. First, you understand this one. What do you find out? He converts CO into CH2. Okay. Now, I will write. You take any compound as you like. Any compound. For example, acetone. Okay. It undergoing the Clemmensen reduction. Clemmensen means this catalyst. You remember this catalyst. For Rosemond, palladium, barium sulfate. Here, tin bar HCl. What you have to do? You underline CO, and that is smoothly converted into CH2. That's all, propane. If somebody asks you for acetophenone, means you just go for the reaction like this. Ethyl benzene. If somebody asks for acetaldehyde, means for this reaction, you may say, sir, here we don't have CO. No, no. Here also we are having the CO, provided you write the structure form like this. Here also you are having the CO. But here you can't see the CO directly. So, what will be the product? The CO is converted into CH2. So, the product will be ethane. So, in all this category, CO is converted into CH2. Next one, you are going to see Wolff-Kishner reduction. Here also, the answer is same. What you have learned in Clemmensen is same in the Wolff-Kishner. You see, I don't rub anything, but I'll just change the catalyst. That's all. I'm just only changing the catalyst like this. Hydrazine. Just now I told about the hydrazine. Then KOH, ethylene glycol. Ethylene glycol. You should remember this condition, that's all. You can write for any compound as you like. Sir, I want to write the same acetone. Okay, you write for the same acetone. You write for the same acetone. Anything you can write. But it is only applicable for aldehyde and ketones. Don't go for this one. Don't go for these compounds. Here you may think, here the CO may be converted into CH2. No. It's not an aldehyde and ketones. It's only applicable for the aldehyde and ketones. Third one. Fourth one, Stephen reaction. First one, Rosemond, Clemmensen, Wolff-Kishner. Now we are going for the Stephen reaction. What Stephen does? He converts CN into CH2. First you see the basic concept. First you see the basic concept. Then only you should go for the reaction. Okay, now I'll read the just tell the reaction. Here you can write the triple bond. Here you can write the triple bond. Okay, these are the condition for Stephen, stannous chloride, HCl. What will happen? 2H will join here. You see, 2H will join here. Don't write like this in your exam hall or in your school exam because they don't accept like this. But you should think like this. That's very important. What I'm trying to say is, when 2H are added to this triple bond, the triple bond is converted into a double bond. That's all. Like this. Convert into a double bond. Which on further hydrolysis changes into aldehyde. Changes into aldehyde. That's all. Here I just made a mistake. What should I write? CHO, not CH2. I should write CHO. So Stephen, what he had done, he converted a cyanide into an aldehyde. You see? Cyanide into aldehyde. That is a basic reaction. Okay, this is Stephen is over. Now we are going to see the next one, Friedel-Crafts reaction. If anybody asks Friedel-Crafts reaction, you can write any example because we are having many Friedel-Crafts reaction. But here, first one is acylation. Acylation means acetyl chloride plus benzene. Acetyl chloride plus benzene. Catalyst is as usually anhydrous aluminum chloride. You remove this HCl, the product will be acetophenone. You see, when you use acetyl chloride, the reaction is called as acylation. But we are using benzene to form acetophenone. If somebody asks you benzoylation, you see, it is not benzyl, benzoylation, then you should go for benzoyl chloride with benzene. As usually, same anhydrous aluminum chloride. You remove the HCl as usual, the product will be benzophenone. That is acetophenone, here is benzophenone. So this is the Friedel-Crafts reaction regarding aldehyde and ketones. Okay, next one. Next one is Etard reaction. Etard reaction. What is the basic about the Etard reaction? Is able to convert CH3 into CHO. Is able to convert CH3 into CHO using chromyl chloride like this. Using chromyl chloride. You see, first I am writing the toluene, then as usually chromyl chloride, carbon disulfide, you put the ring as usually, and here you should write the intermediate compound very carefully like this. You should write the intermediate compound very carefully. You see, this is an intermediate compound, OCRO, HCl, it twice. Then which on hydrolysis? You know this one, the final product. It converts into aldehyde. You see, the methyl group is finally converted into aldehyde group. This is called as Etot reaction. Next one, Gattermann-Gooch reaction. Gattermann is entirely different from Gattermann-Gooch. Gattermann means it comes under benzene diazonium chloride. So, okay, what he finds out? He converts H into aldehyde. Here he converts H into aldehyde. That's all. You see, you take benzene, you are having H here, and treat with COCl, CO plus HCl, and slowly learn the catalyst. Aluminum chloride, cuprous chloride, anhydrous aluminum chloride, cuprous chloride. What is the product? You see, what is the product? Benzaldehyde. That's all. The product will be benzaldehyde. So, regarding Etot reaction means it converts methyl into aldehyde. Regarding Gooch means, Gattermann-Gooch means it converts H into an aldehyde. You learn the first basic one, then you can feel it's very easy. Okay, next one. Next one is skip base. Next one is skip base. So, okay, skip base means you should take aldehyde like benzaldehyde with any primary amine, But I am choosing aniline. For my convenient, I am choosing aniline. So, what will be the product? You see what's here? C6H5, CH, O is removed, H2 is removed. Since you are removing 2 hydrogen, what you should do? You should create a double bond. That is a technique. When you remove 2 hydrogen means a double bond. When you remove 1 H means single bond. Then what is the next one? N. C6H5. That's all. Don't buy out all these compounds. This is only skip base. This is called as skip base. Okay. Next one. Next one is aldol condensation. Aldol condensation. The name itself indicates aldehyde alcohol. The name itself indicates aldehyde with an alcohol. So, okay. You see, you take acetaldehyde, 2 acetaldehyde, then what you do? You just write like this if you want to understand very easily. You see, since we are having 2 carbon, we are having 4 carbon here. Because of aldol, there is an aldehyde group, there is an alcohol group. This is a skeleton form. You should not write in an exam. But by writing the skeleton form, you can create your own complete structure. How it is possible? Here you should write CH3. Since there is a group, you should take 1 H. Here, since there is no group on top and bottom, CH2. This is aldol. This is for your initiation, how to write. But don't write these one in your exam hall. they will not accept. Okay. Next one, if somebody, I'm just misuse a catalyst. This is a catalyst. This is a catalyst used for the aldol. But in a book, they are extended this equation to heating also. I'll do it for you. When this compound is heated, what is the product? Don't learn all this. Organic means water. 99% organic means water. You just remove the water like this. You can write the product. You can write the product. That's all. You can write the product. You see, OH from this carbon, H from this carbon, you create a double bond, that's all. The name is crotonaldehyde. Or you can name the IUPAC name also. Anything you can like. Okay. Next one, what you are going to learn? Crossed aldol condensation. Next one, we are going to see crossed aldol condensation. Okay. Crossed aldol condensation means like this. Acetaldehyde plus propanaldehyde. Like this. When you use two mixture, it is called a crossed or mixed aldol condensation. For acetaldehyde, this is an expected reaction. Going further and again, last two, what you could say, crotonaldehyde. But for this one, I am going to write here like this. CH3, CH2. Why I am writing instead of 1-methyl, 2-methyl, instead of methyl, why I am writing ethyl? Because they have created one more carbon. Okay. Then what will happen? CHOH. Because of the hydroxy group. Then instead of CH2, you write CHCH3. This is a aldol formed. You can check whether it's right or wrong. How could you check? You see 1, 2, 3 carbon, but because of 2 means totally 6. 3 into 2, 6. So 1, 2, 3, 4, 5, 6. What is the product formed when this is heated? You can guess. Like this OH and this H. So by seeing this, you can write the answer. You see CH3, CH2. Then what are you going to do? CH double bond. You see, CH double bond C. CH3, CHO. That's all. CH3, CHO. Again, I am going to repeat this one. This is aldol. You can write from the skeleton form. You can remove water, OH from this one and H from this one. Create a double bond. That's all. And in this case, what will do? OH from this one and H from this one. What is the difference between these two compounds? This and this are newly introduced. You see, these two groups are newly introduced because of extra CH2. Okay, this is crossed aldol condensation. Next one, we are going to see Cannizzaro reaction. We are going to see Cannizzaro reaction. Cannizzaro means indirectly both oxidations and reduction are taking place in aldehyde. I'll write like this. You see, I am writing benzaldehyde with an alkali. What I am going to do? One aldehyde is reduced. When any aldehyde reduced, it converts into primary alcohol. Be careful, don't be a playful. What will do? Somebody are writing like this. This is wrong. This is not at all alcohol. What I am just insisting again and again, CHO will be converted into CH2OH. So, okay, don't write phenol. Then what about this one? The other aldehyde will be oxidized. When I say oxidized means, what you will say? Sir, acid. You will say acid. See, you will get the acid, but because of the presence of an alkali, this will not keep quiet. What will do? It converts this acid into a sodium salt. That's all. It will convert into a sodium salt. This reaction can be applied even for formaldehyde. You can apply for formaldehyde, methyl alcohol plus sodium formate. So, this is what is called as Cannizzaro reaction. Next to reaction, hydration of alkynes. Alkynes means triple bond. You see, I am writing a triple bond compound. I am going to do the hydration in the presence of these two conditions, mercuric sulfate, sulfuric acid. First, what I am going to do, I am just adding like this, HOH. By seeing this, I will write like this. You see, the triple bond will be converted into a double bond. Next, what will happen? This H rearranges to this side. So, the final product will be CHO. The final product will be CHO, that is an aldehyde. So, in this reaction, what happens? All triple bond acetylene or ethyne is converted into acetaldehyde. Okay, when you have this formula, when you apply for propine, what you will say? You will write like this. You see, when you apply for propane, you write like this. For propane means OH at the middle, H in the corner for propine. So, you write like this. Like this. OH, H means triple bond converted into a double bond. Then what will happen? As usual, rearrangement. They will go for rearrangement like this. That's all. You will get acetone. The H will come over here, the double bond will be shifted over here. So, the final product is acetone. Next one, nitration. Nitration for benzaldehyde, acetophenone. These are all very easy. These are nitration using concentrated nitric acid, concentrated sulfuric acid, what you should learn? Sir, which directing group this belongs to? Meta. If the meta means go over, then you write as your own. You see, you can write by your own like this. Meta nitro benzaldehyde or meta nitro acetophenol. That's all. When you know the directing position, you can write by your own style. You need not depend upon the book and all. Okay, next one. With cadmium chloride, you see, with cadmium salt, you see, the methyl magnesium bromide reacts with the cadmium chloride. Cadmium means valency 2. You should remember the valency 2. So, you write dimethyl cadmium plus MgClBr like this. Dimethyl cadmium, MgBrCl. Then what will happen? Again, this is a second step. What will you do in second step? You write 2 acetyl chloride. You write 2 acetyl chloride, one in the straight form, one in the reverse form. And you write the dimethyl cadmium like this. Dimethyl cadmium like this. We are just creating an artificial arrangement for all this reaction, because then only you can understand something like this. You see, cadmium chloride will be removed, these two combine, these two combine. So, the product will be 2 acetone. You see, the product will be 2 acetone and cadmium chloride. The product will be 2 acetone, this one acetone, here one acetone, CH3, CO, CH3 with cadmium chloride. If you want, you can have a double bond, that's your willing. You can create a double bond and you can write according as per your style, that's all. Now, we are going to see carboxylic acid. In carboxylic acid, only 2 are naming reaction. One is Gibbs electrolytic reaction. Gibbs electrolytic reaction or electrolysis. This is already seen, but again I am repeating for you. You take sodium acetate. Because of the ester, it is called ate. You write sodium acetate, you do the electrolysis. You do the electrolysis. What will happen? These two combine, and these two combine. That's all. Okay, then what will be the product? CH3 plus 2 carbon dioxide plus 2 sodium. That's all. But see to that, be careful, don't write the bond here. Why? They are all individual compounds. I am writing the individual compounds right above and below so that you can understand. That's why I am writing like this. So, okay. Second one is HVZ reaction. Now, next one we are going to see HVZ reaction. Hell Vollard Jelency reaction. Okay. For this, you are taking this one as a reactant. When treated with X2 using red phosphorus and water. X can be chloride or bromide. Okay. What is the answer for this? this hydrogen will be removed or substituted by the X. That's all. It is easy to replace OH by using PCl5, PCl3, etc. But it's not easy to remove this hydrogen. So, these group of 3 scientists were able to replace the middle hydrogen into X. So, they called us Hell-Vollard reaction. Next one. Acetic acid in the presence of P2O5. You see, acetic acid in the presence of P2O5. This reaction will be given in the book in the form of a highly complicated double bond. Avoid all this. Okay, you should write plus. Why? Because these two compounds are individual, not a combined one having a bond. The answer is very simple. What will be the answer? You remove the water. Organic means water. Organic means water. That's all. You remove the water. That's all. The product will be acetic anhydride. The product will be acetic anhydride. Next one, decarboxylation. Already I just told you in general reaction. What is decarboxylation? Remove the acid using soda lime. You should use this reagent for decarboxylation. You see, you take any sodium salt and treat with the sodium hydroxide, calcium oxide. This combination is called soda lime. Now, this is not called soda lime. This combination, so you remove that one. That's all. This H will join to this, merge with this to form methane. This is called decarboxylation. Then benzoic acid. Benzoic acid with nitration. Already I told you how to understand this reaction. It belongs to electrophilic substitution, and this acid belongs to meta-directing group. So, the product will be like this. The product will be meta-nitrobenzoic acids. The product is called meta-nitrobenzoic acid. That's all. See, this reaction you should not learn here. But I'm telling here because it is in your book. But this reaction you should learn from common reaction. Okay, last one. Carbon dioxide with Grignard reagent. This also I already mentioned in common reaction. Carbon dioxide with the Grignard reagent. Finally, it reaches to acid. Finally, this also reaches to acid by hydrolysis. By hydrolysis, it reaches the acid like this, acetic acid. So, keep it in mind, when carbon dioxide is treated with Grignard reagent, it gives a corresponding acid. When you use methyl, you will get acetic acid. When you use phenyl, you will be getting benzoic acid. You will be getting benzoic acids. Okay.